action. Okay, do you guys remember the simple interest formula from yesterday?
Something.
Okay, so what did P stand for?
No.
Principal.
Yes, principal. Now we're not really doing money today. Some of it's money, but we're not really doing principal today. So today that just stands for the initial amount. So this formula is not really, since we're not doing money today, it's just called the exponential growth formula. Exponential because it has the exponent variable. Exponential growth formula. Okay, our yesterday was interest rate. Today it's just like growth rate. I think the book actually uses the word, it just says percent change actually. That's the word they use, percent change. Like the temperature increases by 2% every day or something like that. Percent change, and T still stands for, guess what? Time. Alright. Now time, when you're talking about interest, it's measured in years, but you can measure in seconds or days, or like I said earlier, if the temperature goes up 1% every day, the T would stand for days. Okay, so we have the initial amount, the growth rate, which is like a percentage rate, like how much is it going up. So it also could be they call it percentage change because it could be a drop, a decreasing rate. Like if the cost of milk went down or something, that would be like a negative, like the price is dropping. So if the rate was like 4%, you'd have like 1.04 in the parentheses, right? Remember 4%? So to change to a percent, you move the decimal twice to the left, and to change from a percent to a decimal, you move the decimal twice to the left. To change from a decimal to a percent, you move the decimal twice to the right. So what would like the number 3 be as a percent?
0.03.
300%. Um, 0.03 is 3%, but 3 is like 300%. If something is 300% of what it was, it's like 3 times what it was. That's anyway. Oh yeah, I remember what I was going to say. So if the growth was 4%, it's like 1.04. If the growth was negative 4%, so it's actually like a decay, 1 plus negative 0.04 would be 0.96. So in this case, if it's less than 1 in here, that means it's a decay. Or if this is negative, that's a decay. It's going down. But if it's positive, if this is bigger than 1, or if it's a positive growth rate, it's a growth. This number in here, like when you simplify it, they call the growth factor. The reason is because a factor is a number that you multiply, and this number gets multiplied over and over again. But yeah. So the whole thing is a growth factor. There is a little bit of a tricks on this, but you guys probably like this one, right? Fairly straightforward-ish. Now, there is one question I remember, I kind of forgot, but with compound interest like yesterday. So what was the compound interest formula that we just created? Yeah, so that K gets added in a couple places. K stands for how many times you get paid per year, like monthly is 12, daily 365, quarterly 4, semi-annually 2. Yeah. That's almost everything. You track all that. We'll see how we do. Okay, number 1 says, for each exponential function, identify the initial amount, the percent change, the growth factor, then state whether the function models exponential growth or exponential decay. So we got 4 answers. So number 1, what is the initial amount? 20. That's the easy question. Second question, what is the percent change? Well, this number right here, the 3/10, is the change. But we need to change it to a percent. So what's 3/10 as a percent?
30.
Yeah, if you did 3 divided by 10 in your calculator, it'd be like 0.3, but you need to change that to 30%. Also, it's a minus 30%, like it's dropping off. So it's a negative 30% change. Okay. Third question is, what is the growth factor? No. The growth factor is like the parentheses simplify. Yeah, 1 minus 3/10 is 7/10. So you could say 7/10 or 0.7. Is this an example of exponential growth or decay? Decay because this is going down, it's like negative, or this value is less than 1. If you multiply by 0.7 times 0.7 times 0.7, you keep getting smaller and smaller numbers. If you multiply by something bigger than 1, you get bigger and bigger numbers. But yeah, this one's decay. Number 3, what is the initial amount? 42. Now, notice on number 3, in the parentheses, they don't have 1 plus something. They just put it together as 1.5. So, what must the R, the percent change, be to turn it into 1.5? Must be 0.5, right? 1 plus R equals 1.5, so R must be 0.5. But what's 0.5 as a percent? 50%. Do you guys know how to increase something by 50%?
Yeah.
Like if you were paid $10 an hour and then you got a 50% pay raise?
Times 1.5.
Well, yeah, or times 0.5 and add that on, yes. So you'd be, yeah, $15 an hour. All right, anyways, next question was, what is the growth factor? Yeah, since they already simplified the parentheses, that is the growth factor. It's the number that gets multiplied over and over again. Is this an example of growth or decay? Growth.
I have a question about 4. Because there's no initial amount.
What do you guys think the initial amount is on 4?
0.
1. If you multiply 0 by numbers, it's going to say 0. So there's an invisible 1 on the front because, yeah, nothing's on the front. Okay, number 5, H of T. So what's the initial amount? 1/2. Okay. So in the parentheses, 1 plus R, what must R have been to get the value of 1/2? Yeah, you could do this algebraically if you needed to, but negative 1/2. And what's that as a percentage? Negative 50%. Something's getting cut in half. What is the growth factor? 1/2. It's the parentheses simplified. 1/2. There you just wrote. Is this an example of growth or decay?
Why?
No, thank you.
Goodness.
And now
No.
there's a random dot that kind of looks like a heart.
It does look like a heart.
Oh, wow. Wow. Bum, bum. Bum, bum. Bum, bum. Bum, bum.
That reaction. Really?
Always have so much energy.
I do?
Yeah.
Not always, no.
Do you have a hammer out?
Yeah. Wait, was there one?
No, not yet.
Oh, okay. So why'd you say anything?
I think you know. Why'd you
Okay.
put this
Number 7, what's the initial amount?
10,000.
What is the percent change? So how do we turn 1 plus r into 0.975?
2 to
The r must be, like going down 0.025. What is that as a percentage though?
Negative.
Right, move the decimal twice, negative 2.5%.
I grabbed that earlier.
Yes, you did.
Okay, what's the growth factor? 0.975, take in the parentheses. And then what is it growth or decay? It's dropping 2.5%, so it's decaying. Number 9. Write an exponential function modeling each situation and state whether the function models exponential growth or exponential decay. Then evaluate f of 5 and f of 12 for each function. So they're giving us a situation and we're supposed to put the function that goes with it. So a $33,000 car is expected to lose 1/6 of its value each year. So on all these, I'm just going to start with the A of t, kind of like yesterday. Variable will be the t time. All right, what's the first number? Look how big that is.
33.
33,000 is the initial amount. Okay. The car is supposed to drop in value by 1/6 every year.
1 minus 1/6.
Right. 1 minus 1/6. What's that simplify to? Let's go ahead and simplify it. You have one cookie and you eat 1/6 of the cookie. What's left? 5/6. It's always a cookie.
Extracurriculars or that's decay.
Oh yeah, is it growth or decay?
Mark it.
Don't mark it. Sounds so official.
It is official.
Time of death. You're a little late. You ran a little bit late, Lydia.
Darn. Disappointed.
What was the last question? Oh yeah, what's f of, or I put a, didn't I? Okay, so what's a of 5? They said f of 5, but put A's.
Does that mean you put 5 in?
Okay, yeah, the variable is the time, t, so you just plug in 5, and they ask for a of 12, or f of 12, or whatever. Also.
What?
So yeah, you just plug in your calculator, 33,000 times 5/6 to the 5th. And then, you guys know on the calculator you can just, like, you don't have to retype it again, you can just go back and
Delete.
delete the exponent and turn it into a 12. On every calculator, there's some way to do it, unless you got a really dumb calculator. I don't think anybody does.
Maybe Trey, but it's not the calculator.
Oof. Ouch.
Operator here.
Can you solve
Say a word.
How does it feel?
Oh, he knows from math class.
Like Trey doesn't know how it feels to be bullied.
Goodwill Drew.
No one,
Goodwill
no one was
Tree.
as bad as when Mr. Nelson was.
Oh my.
That was harsh. It was.
I thought we agreed that the harshest was when Trey got a haircut and what you guys did to him.
That was
That was bad.
bad.
Not that bad.
Trey, was that one of the hardest days of your life?
That was one of the hardest days of my life.
That was last year.
That was last year.
I didn't get to experience that. It was like the shock.
It was awful.
I got paid 200. Was it worth it?
And it wasn't worth
It
it.
wasn't worth it, was it? No.
Abby, did you ever see him pre-perm?
Yeah.
You did?
Yeah, she got it like late in the year.
Did he?
Like
I thought it was
the whole
earlier.
year.
It never went away.
And then I cut it short with Leo. And that was just everything all over again.
Okay, we're talking about money on this, so it makes most sense to round it to the 1 cent place. Did you guys, anybody get the 12 one yet? $3,701.
Let's do the next problem. I've been more claps.
You were a yard clap.
Williams didn't look
Check
bad.
out back then, Sebastian.
Oh, then
That's a lot of
all we need is Sebastian to get a buzz now.
Absolutely.
You would really
Sebastian,
get
You
Kimmy.
would get murdered.
So bad. I feel like
You
your
know,
head
why
size
did I-
this to like this.
Yeah. Sebastian, if you ever,
Like
Have
your
it-
dog
I think you have a
really
skinny
big.
head, just ass like all your hair. That's like to here.
He'll wake up on that from youth group and his hair will just be gone.
if you ever have a hair issue, Sebastian, you probably just want to transfer school.
Yeah.
Just go.
Sebastian was
Just
Then
go.
they get-
For your mental health,
Oh, he never gets cancer.
take a lesson from Trey. Okay, number 11, a telecommunications company plans to expand its. Okay, so they have 220 employees and they want to go up by 3% every year.
That can be 0.0.
Yeah. So they're starting with 220 and they're going up by 3%, which is 0.03. So 1 plus 0.03 is 1.03. Easy peasy. All right, is this growth or decay?
Growth.
And then we need like A of 5 and A of 12 again. Okay, the 5.
255 and 466.
Okay, this one is talking about people, so where would we probably round it to? Nearest, probably nearest person, yeah.
227.
Yeah, she died.
Probably. 227.
Your face, you're like,
You guys did good.
I got 255.
Didn't she go to the
I think that one was right.
Yeah.
Which one's right?
255.
You fried. Yeah.
Just kidding.
Who got it wrong? Oh, I didn't move the decimal place enough.
Yeah.
Okay, wait, what?
Does that mean the next one
The
is
other one was
300?
300 and something.
314.
314. That seems familiar.
Wait, I'm still getting 226.
You're doing
Wait.
Did you put a, I don't know. Did you put a 5 right here.
Okay, I got you.
1/3 is 30%. 3.
No fun in math class. Stop it. Okay, 13, we have not talked about half-life. Have you guys talked about half-life in science?
No, not exactly.
It's, well, okay, the juniors have, I didn't think you
That's
probably had.
next semester for you guys.
We are in next semester.
Okay.
Next year.
Oh, yeah.
Well, there's a little formula up above that gives you the half-life formula. It's basically the value is going to drop by 50%. But the trick is, I want to explain. It's hard to explain. The half-life tells you how long before something is half of what it was. That's what it means. So in the H is where you put the half-life in the formula.
Wait, what?
The half-life is how long it takes before something is half of what it was.
Okay.
So when they talk about like radioactive elements in the half-life, it's
Yeah.
because they take so long to decay.
Explain that to me like I'm 5.
I would.
Chunk of rock.
I tried.
I want to get an X-ray of Leo's brain.
Okay,
This is great.
It's just,
if one of you walks out like once per minute, it would take like 5 minutes before we're down to half. But it's a little more.
Okay, does everyone else but Leo get it?
yes.
Explain that to me like I'm a dumb butt.
Let's plug the numbers in then. Maybe it'll make more sense. It is a little bit confusing. So like, yeah, radioactive material, over time it gets less radioactive, but
Yes.
like every
Like
1,000,
what?
every 10,000 years it's like half of what it was, and then another 10,000 years it's half of that, and then half of that.
Okay.
So kind of slowly, it kind of does this. It gets,
Less by half.
you know. Okay,
Because she was so reactive.
so on number 13, this is the general formula. I just copied that from above. The initial amount is 50.
Isotope.
It's going to be half of what it was. The half-life is 8 minutes, so you put a little 8 right here. Okay, the reason this works is what's going to happen when t equals 8, when you have 8 after 8 minutes. This would be a 1, so this would be a 1/2, so it'll be half of what it was.
Okay. Oh, so that means.
So in
okay.
16 minutes, it'll be a 1/4 of what it was. Anyway, that's good enough understanding. Okay, is this a growth or decay? Yeah, all half-lives are decaying.
Is 14 the same as this one?
No, 14's actually from yesterday,
Oh, sweet.
from the compound interest.
Excellent.
Okay, and we still do need to do what's AO5 and AO12.
Yeah, but I still want to hear the answer for this one. Or do.
So we're talking about, well, grams of something. So I think they just rounded to the 10th place. 13, they put 32.4.
When the baby was. I can't tell if that's. Wait, here. Yes, it was. It's kind of hurtful.
You guys did good, right?
Farewell.
What?
There's probably some in that.
I'm actually gonna just stop there.
Really?
Yeah.